Hey there, welcome to 8.6. Our SWAT is the factor polynomials for this lesson. We've done our warm-up already, and so we're going to proceed to the next slide. We are going to be factoring trinomials again the same way that we've used before in 8.5. Only difference is that now the leading coefficient is not 1. However, because we learned it the other way, we're going to just apply it the exact same thing yet again. So the first thing we did before was we put the first term in the first box and the last term in the last box. Now, where I'm looking for two numbers that will multiply to give me 4x squared times 10, that's 40x squared, and that will add to give me 13x. I do mean 13x. So you're thinking and you're going down the list. Okay, 40, 1 times 4. Not gonna 1 times 40, also known as 1 times 40, doesn't work. 2 times 20, not it either, because when I add them I don't get 13. And then I'm thinking, okay, 4 times 10 does equal 40, but not when I add it. And then I'm thinking 5 times 8 equals 40, and then I feel really good because it is 8x times 5x gives me 40 when I multiply, and then 8x plus 5x gives me 13x when I add. So those will go on my diagonals. Still doesn't matter which one you put where. So now to factor, using my factor box, what goes into 4x squared and 5x? Not much, just an x. What goes into 8x and 10? Just 2. Then looking from left to right here, what goes into 4x squared and 8x? Well, 4 goes in to both of the numbers. It's the biggest number that goes in both of them. And they both have at least an x. I'm going to take an x out. And then 5 and 10, what goes into both of those? 5. So this in factored form is x plus 2, because it's a positive 2, times 4x plus 5. And there you go. So same first steps. First term, first box. Last term, last box. So now I'm looking for two numbers that will multiply to give me 8m squared times 5. That's 40m squared. What a coincidence. And then that will add to give me negative 22m. So because this is positive, I know that I need a positive times a positive or a negative times a negative. Because they have to add up to a negative number, I'm thinking probably a negative and a negative. Let's check out some factors. So I started here, 1 times 40. If I add them, I get 41, not negative 22. Doesn't work. 2 times 20 does equal 22 when I add it, so that's a good thing. However, it needs to equal negative 22. So what can I do? I could do negative 2m times negative 20m. When I multiply them, I get negative 40m squared. And when I add them, negative 2m plus negative 20, signs are the same. So I add the numbers and keep the sign. So that's a winner. So I'm going to put negative 2m here, negative 20m there, and then I'm going to start to factor. Remembering this, you're always going to take the sign that's closest to the edge. So let's look at this first column. 8m squared and negative 20m. Well, what goes into 8 and 20? Biggest number I can think of is 4. What goes into m squared and m? Is it positive or is it negative? Well, this is the line that's closest to it, and it's positive, so I'm going to keep that positive for m. Now, negative 2m and 5. What goes into negative 2 and 5? Just 1. But what's the sign closest to the edge? Negative, so it's going to be negative 1. Keeping it pushing. 8m squared and negative 2m. I know it's going to be positive because the number closest to the edge is positive. What goes into 8 and negative 2? 2. What goes into m squared and m? Negative 20m and 5. Negative 5 is in common for both of those. So, and remember, this is the sign closest to the edge is negative, so this is negative. So 4m minus 1 times 2m minus 5. And that's my final answer. Same process as before. So I'm going to have you try to do C and D on your own, and then you can press pause to check your work with my work. So just a quick check-in for letter C. I needed two numbers that multiply to give me negative 36x squared, and that add to give me negative 5x. So because my result is negative, I know one sign has to be positive and one has to be negative, so I end up being subtracting the numbers basically. So negative 9 times positive 4 is negative 36. Negative 9 plus 4 is negative 5x. So that's what I put on my diagonals. And then I factored from there, here, and then from left to right as well. So this was kind of a good problem because instead of adding to this number, you kind of have to end up subtracting them because the signs have to be different. Okay, and then for your last one, hopefully you put your 4k squared and your 5 here. And then you were looking for two numbers that multiplied to give you 20k squared and added to give you negative 12k. And when you were coming up with those numbers, I believe you found that negative 10k and negative 2k worked. If not, go ahead, press pause and get ahead of me. And then you put those on your diagonals, of course. And then you factored each column and then each row as well. And this is the result that you get. So 2k minus 5 and 2k minus 1. That's the check one to make sure that you're okay. So press pause, and then I believe on your paper you have a little spot there. If you have any questions on this part, if there's anything where you're like, I don't know how'd you do that, Ms. Fitzgerald, write that in that blank square that you have there. Any questions that you're not sure about, anything you're not sure about, any questions you have on that part. All right, keeping it pushing though. So that's what you're doing in this blank square. Any questions? And then we're going to look at the next lesson. So kind of switch modes a little bit. Press pause if you need to write down your questions or anything you need clarification on. 8.7, a little different. No boxes for this one whatsoever. It's similar. It's like the complementary part of it is what we did in 8.4. We had those special products. The only difference is instead of multiplying using special products, we're going to be factoring using special products. So I want you to use this. I don't want to see any factor boxes for this whole lesson. The first one is, it's the opposite way. So you've had a squared plus 2ab plus b squared. This is a trinomial because it has 1, 2, 3 terms. It's a perfect square trinomial because the first term is perfect square and the last term is a perfect square. If we were to factor that, we would get a plus b squared. The other perfect square trinomial that you've learned about is minus 2ab instead, and this is equal to a minus b squared. So we've gone from this way to this way, and now we're just going the opposite way because now we're factoring instead of multiplying it out. Difference of two squares. Well, difference means subtraction. Two squares, so a squared is a square, and b squared is a square. This was equal to a plus b times a minus b. Again, you've seen it, you've learned it, but now you're going to go the opposite direction. So I still want you to memorize these formulas. But before we go on, I'm saying the word perfect square a lot, and I'm saying squares. Let's just quickly jot down a list of perfect squares. So like 1 squared is 1. 2 squared is 4. 3 squared is 9. Write these down. 4 squared is 16. 5 squared is 25. 6 squared is 36. These are perfect squares because when I take the square root of them, it's a perfect number. I don't have any left over. It's not like 1 point something. It's just 1. 7 squared is 49. Then 64 for 8 squared. 81. 100. 121. 144. Dot, dot, dot. I want you to develop a sensor in your mind so that when you see these numbers, an alert goes off. And it's going to be like, doot, 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 doot. Yep, just like that, only louder and in your head. So my directions here are to factor, and we have those special products to kind of help us out. So this one looks like, which one? Is it a perfect square trinomial? Nope, because there's more than 2 terms. It's 3. It's the difference of 2 squares, but these don't look like squares yet. This is on my perfect square list, and this is on my perfect square list. That means these are great numbers. So here's the pattern I'm using. A squared minus b squared. Doesn't look exactly like that though. Well, what squared gives us 36x squared? Well, I know x does. What squared gives you 36? 6x. So 6x squared gives me that. And then what squared gives me 49? If you said 7, even if you just said it in your head, you're correct. So it looks like now I have my a and my b. So what was this equal to? This was equal to a plus b times a minus b. So my a was 6x plus b, 7, times a, 6x, minus b. Oh, minus b, which was 7. That's it. No box. If we remember these special products, guys, I promise you, your life will be made way easier. Okay, I also like to do this. I like to do a little bit of a check. Is there anything that I can factor out of 25, 20, and 4? No, but I did check. So then my alert is going off. I see that this is a perfect square, because this is just like 5x squared. 5 squared gives me 25. X squared gives me x squared. And then the same thing with this 4. What squared gives you 4? 2. How many terms do you have here? 3. This is a perfect square trinomial. Again, it's a perfect square trinomial. So you're looking at one of these two. Because it was subtraction in the middle, I should be looking at, I'm going to write it down, and I want you to write it down too. There. So if this is correct, and it is, then I can just write this as something squared. Well, the a in this case is 5x, and the b in this case is 2. If it's minus in the middle here, it's minus in the middle here. Now you're thinking, well, whoa. What about this 20x? Well, remember this formula. It's minus 2ab, right? Minus 2ab. The a we say is 5x. The b we say is 2. Let's see what happens when we multiply this, as if I don't know. Negative 2 times 5 is negative 10x. Times 2 is negative 20x. Negative 20x. We have a winner. That's how you check yourself with these. Now, if that did not work, then you would just use a box instead to multiply it out. Okay, looking at number 3, do they have anything in common? Not so much. So go ahead and use, I'm going to kind of set you up here, a squared plus 2ab plus b squared equals a plus b squared. Do me a favor, press pause. I'm giving you the, not yet, a squared minus b squared. I'm giving you the formulas, and I want you to try these ones without me. So press pause, go solo, try it. Okay, so what squared gives you m? What squared gives you 81? 9. So m plus 9 squared. Some people go a little too far, and they're like, oh, 9's a perfect square, and they write m plus 3. That's wrong. Don't do that. And then this is 3k plus 4 and 3k minus 4, because it's the difference of two squares. What squared gives you that? That's 3k minus 4. Okay, delightful. Last one. These numbers are huge, and I want you to stop here just for a moment. Remember that check. What goes in, is there something? The answer is yes. That goes into 100, 160, and 64. There is, and that number is 4. So I'll take out a 4, and I have 25 x squared minus 4 goes into there 40 times, and then plus 16. It's still a perfect square, trinomial, but I had to take out the 4 first. So now I have 4 times, if it's a perfect square trinomial, I'm going to break this down into one set of parentheses, the same way that you did for number 2. So what squared gives you 25? 5x minus what squared gives you 16? 4. And then you can check yourself. 2 times 5 is 25. Just kidding. It's 10. And then 10 times 4 is 40. So that works out well. So this is my whole answer for that one. Okay, for this one, should be difference of two squares because there's only 2 terms, but it doesn't work. So I'm looking at this, and I know that 2 goes into both of them. And I have b squared minus 9 left over. And then from here, you can use your difference of 2 squares, which is right there. So this is going to be b plus 3 and b minus 3. And there you go. Thank you so much. That's the lesson for today. And have a good one.